In the last video, I showed that if I put a magnet above a superconductor, it kind of just floats there like magic. What I want to do now, though, is show what happens if I do it the other way around. For this one, I'm using a much bigger superconductor, and I'm again cooling it with some liquid nitrogen. By now, it should be good, and I can take it out and drop it onto this little magnet track that I made. It actually stays on the track, and if I push it, it's able to move without falling off. It's also surprisingly strong, and even if I push it decently hard, I can't get it to touch the track. As it warms up, though, it eventually loses its ability to superconduct, and it stops floating. A little while ago, I made this little thing on my YouTube channel, and it's called a YBCO superconductor. At room temperature, it doesn't do very much though, and I first need to cool it down using liquid nitrogen. Now that it's nice and cold, if I drop a magnet on it, it just floats. I can also poke at it a bit and get it to spin around, and it honestly kind of feels like magic. Here I have some mercury, which is the only metal that's a liquid at room temperature. What's cool about it is that it can dissolve most other metals and form something called an amalgam. This is commonly done to purify gold and to separate it from raw ore. What I think is fun, though, is to just throw some gold leaf onto it. As the mercury dissolves it, the gold is slowly pulled in, and it kind of looks like it's eating it. It's able to suck up a lot of them, and I can just keep adding more. That can come in a few different forms. One of the most reactive forms is white phosphorus, and a while ago, I was able to get some chunks of it. It's stored underwater to protect it from air, and the moment I take it out, it starts smoking. This is because it's reacting with oxygen and letting off phosphorus oxides. It's often used to make large amounts of smoke, but it's also sometimes used as a weapon, which is a bit terrifying. This is because white phosphorus is not only very toxic, it's also super hard to put out when it's on fire. To test this, I'm just going to light this small piece. It immediately starts burning and splashing, but I can put it out by just smothering it, which makes it seem not that bad. However, because it's so reactive with air, this is what happens when I take away the dish. This is some chromal chloride that I made about a year ago, and it's one of my favorite chemicals. I'm not sure why, but I've always been a big fan of dark liquids that let off scary looking fumes. When there's a whole bunch of it, it almost looks black, but in small amounts, it almost looks the same as blood. I mean, if you ignore all the corrosive and carcinogenic vapor. Just like other angry liquids, it can be a bit of a pain to store, and it's often best to put it in something like a glass ampule. To do this, I made an ampule from a test tube, and once all the chromal chloride was in it, I sealed it with a blowtorch. This is a mineral called pyrite, and it kind of looks fake, but it's actually completely natural. Pyrite's also sometimes called fool's gold, and it's able to form in a few different ways, but I think that this cube form is the most interesting. What I find weird is that it's shiny and cold like a metal, but it's not a metal at all. It's also very brittle, and it can break quite easily. So today, I'm going to be making some test tube rockets. To do this, I first need a really strong oxidizer, and I'm using pure nitric acid. Now, all I need to do is add a fuel to it, and I'm using something called aniline. This mixture of aniline and nitric acid was used in some of the first rockets, but nowadays, there are more efficient combinations. It's also common to use combinations that don't light on fire on their own, like liquid hydrogen with liquid oxygen. Today, I'm going to be showing you the classic barking dog experiment that I did a while ago on my YouTube channel. To do this, I just have to fill a tall cylinder with nitrous oxide gas, which is the same thing that they use at the dentist. Then after that, I can add a few drops of a solvent called carbon disulfide. Now I just need to cover the top and shake it around a bit. I should now have a mixture of the nitrous and the carbon disulfide, and all I have to do is light it on fire. This is silica aerogel, and it's one of the lightest solids. It's made from a very fine network of silica, and most of it is actually air. All of this air makes it a really good insulator, and I'm able to blast it with a torch like this for a while before it even starts to feel warm. The texture of it is kind of like styrofoam, but it's also very fragile, and it's really easy to accidentally break it. So today, I'm going to be turning this dish into a silver mirror using some chemicals. To do this, I just need to add some water to a beaker and dissolve some silver nitrate. After that, I can pour in some ammonia solution, which causes some of the silver to separate out for just a second. The last ingredient is sodium hydroxide drain cleaner, and I need to wait for it all to dissolve. The solution's ready, but I only need 100 mils, so I'm gonna pour it into another beaker. To get the reaction started, I have to add some glucose, and I can now pour it onto the dish. It's already darkening because small particles of silver are separating out, and I just need to leave it like this for a while. This is 15 minutes later, and now when I pour off all the water and flip it over, there's a nice mirror on the back. This is arsenic. Arsenic's an element and it's classified as a metalloid, which means that it has properties that are between a metal and a non-metal. It can sometimes be found in its pure form like this, but it's usually found combined with something else, like sulfur and iron. Arsenic's very poisonous, and historically, it was pretty common to use it to kill people. People usually used arsenic trioxide, though, because it was sold as a rat poison, and it was the easiest form to get a hold of. Here in Montreal, we've been finally getting some real summer weather, and I figured it was the perfect time to make some vodka popsicles. I don't drink, and I kind of hate the taste of alcohol, but I still thought it could be fun. The freezing point of 80 proof vodka is about negative 27 Celsius or negative 17 Fahrenheit, but my freezer can't go that low, so I have to use liquid nitrogen. It's taking longer than I thought it would, but it should eventually completely freeze. To get it out of the beaker, I just have to run it under some warm water. I now have a chunk of vodka on a stick, but it would be a horrible idea to lick it because it's way too cold. So instead, I'm just gonna try lighting it on fire. It's kind of sad though, because it's apparently too cold to do that too.